Hey there, folks. This is Mr. Young, and I'm going to teach you how to use Table M along with the pH scale. Now, if you are missing page 35 and 36 in your unit pack for Unit 7, don't worry. What you should do is just open up your reference tables to page 6. So you are looking at Table K and Table L and Table M. Okay, I'm going to hit pause and get your reference tables, page 6. Okay, so the first thing we're going to do is just remind you that the pH scale is not found in your reference table. So you have to keep the pH scale in your head. The pH scale is what you're seeing at the top right of the screen right now, okay, up here. And this is what you need to have in your head. The pH scale goes from 0 to 7. Okay, it's called the pH scale, which stands for the power of hydrogen. But weirdly, acids, which have the H plus ions, have the low pH numbers. So acids are anything below 7. Bases are anything above 7. And then at 7, we have exactly neutral, which is like distilled water, because the H plus and the OH minus, when you put them together in equal amounts, make H2O. So basically, I want you to look at this pH scale and look at Table K and Table L and see if, for questions 1 through 6, we should write acid or base or neutral. For example, a pH of 3.4. It's below 7, so we write acid. H2SO3. Look in your reference tables. Look in Table K and Table L. Do you find H2SO3 on the list of acids or the list of bases? Well, you find it on the list of acids. That is sulfurous acid. Sulfuric acid has a slightly different formula. I want you to, okay, why don't you hit pause, try doing questions 3 through 6. Okay, pH of 8.2, that is a base because it's greater than 7. NH3, if you look on Table K and Table L, strangely, NH3, aqueous ammonia, is a base. When you mix it with water, it grabs up the H plus ions and it leaves lots of OH minus floating around in the water. But don't worry about it. If it's listed on Table K, Table L, if it's listed on Table K, it's an acid. If it's listed on a Table L, it's a base. And that's what you really need to know. pH of 6.9, seems pretty close to 7. No, if it is not exactly 7, if it's below 7, it is an acid. If it's above 7, it's a base. If it's exactly 7, then it is neutral. Pure H2O has a pH of 7 because you have H plus and OH minus coming together to make H2O molecules. Now, Table M is a chart about indicators. Indicators are special chemicals or dyes that change color depending on the pH, and they all change at different ranges. They all have kind of funny names. We got methyl orange, bromthiamyl blue. You might want to write BTB next to that. You could write some things. This would be a great time to write some things in your reference tables on page 6. Bromthiamyl blue is known as BTB. Phenolphthalein is another funny name. Litmus is another one. Bromcressyl green and thymol blue. And they all change their color at different pH ranges. So here's what you do to make Table M easy to use. Methyl orange. It can be red or it can be yellow. And all we got to do is take these color names and move them over to the middle column to make a little number line. For example, below 3.1, it will be red. The left color was red. I move that to the left side. Above 4.4, methyl orange turns yellow. In between, it goes through a color change. Some of these pH indicators do have an in-between color. Some of them kind of snap from one color to another. So if the number is in between in this middle range, the best you can say is, well, it's going through a color change. All we do is we're going to do the next thing to make each row a number line. Bromthiamyl blue, we put the yellow over there. Below 6, pH of 6, it's yellow. Above 7.6, it's blue. Phenolphthalein, below 8, it is colorless, so I put an X. Above 9, it is pink, so I put a P for pink. Litmus is going to be red below 4.5 and blue above 8.3. In between, it's changing. Bromcressyl green is yellow at the low pH numbers, blue at the high pH numbers. In between, it's changing. Thymol blue, also yellow at the low pH numbers, blue at the higher pH numbers. So once you have these color abbreviations written in your Table M, you're ready to use Table M. So for example, questions 7 and 8. What color will litmus turn at a pH of 9? So we take the number 9 and we figure out on the row for litmus, where is a 9 going to fit on this number line? Does 9 fit below 4.5? No. Does 9 fit between 4.5 and 8.3? No. Does 9 fit above 8.3? Yes. Litmus is in the blue zone for pH of 9. Litmus will turn blue at a pH of 9. It'll turn red at a pH of 4.4 or below. And if the pH is between 4.5 and 8.3, it's changing color. It might be purplish, but honestly, some of these pH chemical indicators have instant changes where they will just change somewhere from red to blue at some point in between there. Methyl orange at a pH of 2. We take the pH number, we look at the methyl orange row. Where does 2 fit? 2 is below 3.1. 2 fits in the red zone. Name an indicator that is blue in a neutral solution. Blue in a neutral solution. Neutral on the pH scale is 7.0. So what's an indicator that will turn blue at 7.0? Some of these might have two possible answers. I think the answer is Brom-Kressel green. Brom-Kressel green, the number 7 fits above 5.4. That's the only indicator that will turn blue at a pH above 7. Name an indicator that is yellow at a pH of 4. For some of these, there might be two answers. An indicator that is yellow at a pH of 4. You try it and hit pause. Okay, at a pH of 4, bromthymol blue will turn yellow, and thymol blue will also turn yellow. They both, 4 would fit in the yellow zone for bromthymol blue, 4 would fit in the yellow zone for thymol blue. Name an indicator that is yellow at a pH of 9. Hit pause. Yellow at a pH of 9. That's going to be methyl orange. pH of 9 fits in the yellow zone for methyl orange. What indicator appears colorless in HNO3? HNO3, what's that? Well, go look up HNO3 on table K or table L. You'll find it's nitric acid. Acids must have a pH of below 7. So what indicator appears colorless at a pH of below 7? Well, this one's pretty easy. There's only one indicator that is colorless at any pH range. That's phenolphthalein. And phenolphthalein, yes, it is. At a pH of 7, it will be colorless. Question 13 and 14 are just meant to remind you that if you get a number, that if you get a pH number that is exact, that is in these middle ranges that are printed in table M, the best you can say is, well, it's going to be changing color. Because remember, some of these pH indicators have an in-between color. Some of them just snap from one to another. Like bromthymol blue does turn green at some of those pHs in between. Methyl orange is either cherry red or a yellowish orange color, and that's it. It just snaps from one to the other. Okay, so methyl orange, bromthymol blue, and a lot of other indicators, you have to use table M to interpret them and figure out their pH value. Okay, now there are these things called pH strips. Okay, here's Polly in the pH paper. A pH paper or pH strip will have its own special color chart. You might get a chance to use these in lab. If you've ever helped somebody to test the water quality in a swimming pool or a fish tank or a hot tub or something like that, you have used pH paper. pH paper is carefully made with lots of different indicators in it, and so it turns unique colors for every number on the pH scale. So you can, with pH paper, you can tell, this has a pH exactly of 5 or exactly of 9 or exactly of 10, depending on the color that it turns. But if you have indicators that are listed on table M, you have to use the chart in table M to figure out the pH ranges instead of exact numbers. Okay, that's it for table M and the pH scale. Thanks for playing.